Good morning, good afternoon. Welcome to Virtual reInvent. Never thought that we would miss Las Vegas, but I kind of do. I wish we were all together, but we're going to make the best of it anyway. Um, this is Understanding AWS Lambda Streaming Events. My name is Adam Wagner. I'm a solutions architect out of the Northeast of the United States. I've been with AWS about 6 years, do a lot with streaming and especially serverless services. So today we're going to talk about streaming event sources for Lambda, how to scale them, how to monitor them, common issues, and talk about some performance and optimizations with them. We are going to really focus on Kinesis Data Streams and DynamoDB Streams. MSK, the managed streaming for Kafka, is another streaming service that you can connect to Lambda, but just in the time frame, really only had time for Kinesis Data Streams and DynamoDB Streams today. But if you do have a Kafka workload, that service is there and you can connect it to Lambda. I'm not going to go into the basics of what is serverless and Lambda. Really just going to focus on kind of diving deep into Lambda with those two streaming event sources. All right, so let's dive into Kinesis, and specifically, we're going to be talking about Kinesis Data Streams today. Kinesis is a family of services. So there's video streams for ingesting video. There's Kinesis Data Firehose if you want to stream that data into S3, into Elasticsearch, into Redshift. And then there's Kinesis Data Analytics to do analytics over that streaming data. So if you are thinking about connecting a Lambda, doing things like tumbling window or sliding time window calculations with that Lambda, that might be a good use case for Kinesis Data Analytics instead. But today we're really going to focus in on Kinesis Data Streams. The other service that we're going to talk about is DynamoDB Streams. So DynamoDB is our one of our managed NoSQL database offerings. Really allows you to have consistent low latency at any scale. It kind of scales to remarkable volumes, and specifically DynamoDB Streams is basically a change log of any mutating actions that happen on an item within DynamoDB. So you create a new item, you update an item, you delete an item, it's going to end up there on that stream. It's strictly ordered by partition key, right, by hash key, and it's retained for 24 hours. Connect a Lambda to it, and that's what we're going to talk about in detail today. Both of these look fairly similar, right? So with Kinesis Data Streams, you have some sort of client application, data producing application that's putting records onto that Kinesis data stream. We then can hook up a Lambda function. That Lambda function is going to receive batches of records, do something with them, push them to a downstream system. DynamoDB is similar, except that the clients on the left are not talking to DynamoDB Streams directly. They're talking to the Dynamo database. And then again, you have that stream of changes happening there. So a little more detail here. So Kinesis Data Streams, you're going to have the Lambda service polling that stream for you and then executing your Lambda function with a batch of records. The Lambda service is polling that once per second for new records and then handing those records off to the Lambda function. If you have more than one Lambda function subscribed, that Lambda service is going to keep basically different pointers in the stream for how far it's read and hand off those batches of records to the Lambda function in order, right? So there's that in order piece is important. There is a 5 Lambda function subscriber limit for Kinesis Data Streams, and keep in mind that Kinesis Firehose and Kinesis Data Analytics applications also count towards this limit. On the DynamoDB side, it looks pretty similar. A couple of the changes that I just want to point out is that the Lambda service in this case polls 4 times a second. So every 250 milliseconds, it's polling that stream to get new records to send to your Lambda function. The other thing is there's a lower limit on the number of Lambda functions you can have subscribed to that Lambda function, just 2. So let's get a little more in depth, talk a little more in detail about what that Kinesis stream looks like. So Kinesis stream is made up of shards. That's how you scale how much throughput your stream can do. And so the Lambda service really under the covers is not just polling one stream, it's polling the shards, right? It's polling those individual shards within your Kinesis data stream. And then there's a one-to-one mapping by default of concurrent Lambda executions to each shard. So if you see that, the red arrow on the top taking records from that top shard and sending them to that Lambda function, it's going to kind of continue to do that as there's new shards. Those other shards are being processed in parallel. And so that's what gets you that in-order execution, is the fact that for each shard, it's taking those batches of records and only moving on once it's processed the previous ones. So this is important to understand as we kind of dive deeper in and look at kind of what happens per shard. Remember, kind of from here on out, we're looking at kind of a small piece of this where we're going into the specific shard. And so just to simplify this picture here, we're going to break it down to a single shard, right? And I've removed the Lambda service from the middle. It's still there, right? But just for simplicity, to just talk through it, we're gonna look at it this way. So the Lambda service, right, polling once a second, looks for a new set of records, and then synchronously invokes your Lambda function with that batch of records. If the Lambda function returns successfully, it's going to move that pointer of where it's read to, and it's going to grab the next set of records, and it's going to invoke that Lambda function again. If your Lambda function errors, the behavior really depends on how you've configured your streaming event source. So the default settings, Lambda is going to retry that same batch of records, and it's going to keep going basically until the records age out or until that Lambda function succeeds. And so the reason for this is it's just really trying to kind of avoid losing data. But there are other kind of options we can do to kind of avoid that poison pill issue and kind of getting stuck processing the stream. So one option is bisect batch on function error. What this does is it takes that batch of records that errored, it splits it in half, and then it retries each half. And it retries them in order so that it continues to do that in order processing. And so it's going to keep doing that. If that half batch fails, it's going to split it again. And it's going to keep going down until it reaches that problematic record. And that way you process as many records as possible successfully, before kind of error handling takes in. An interesting point here, that last sentence there, all those retries that happen as it's splitting that batch, they do not count towards your retry, max retry setting, which is another thing that comes into play here. So after it's split down and it's down on that single record, those retries are going to count towards this maximum retries setting. And when you get to your maximum retries, it's going to send them to a failure destination if you have them configured. So a failure destination could be an SQSQ or an SNS topic. Very often it's an SQSQ, functions a lot like a dead letter queue. And so those problematic records, actually the metadata of those problematic records is sent to that SQSQ. You can then use that metadata to retrieve that data and process it manually, or log it to handle later. So a little deep dive there on the failure processing. So with that, let's head into scaling and talk about how your Lambda functions are going to scale alongside Kinesis and DynamoDB Streams. So Kinesis, as I mentioned earlier, it scales by adding shards. The easiest way to make changes to this is the update shard count API, when you call this API, you give it the target number of shards, either more shards than you have currently if you're scaling up, or less shards if you're scaling down. And the Kinesis service handles splitting or merging shards to get to that target number for you. You don't have to manage that. There are the lower level APIs. If you want to get more granular, they allow you to split and merge shards specifically if you want to. Taking a look at what that update shard count API looks like. In this case, this is a little CLI example. So we're going to go from 4 shards to 8 shards. It's going to take care of doing those splits to get us there, and then we're at 8. There are some API limits to know about in terms of how often you can call update shard count. A lot of these are soft limits, so definitely raise a case with AWS support if it would help you to have these raised. Most of them can be raised. So throughput considerations. So per shard, there are throughput limits, both in terms of putting records into Kinesis and taking records out of Kinesis. So on the right side, the max messages that you can push in are 1,000 messages or 1 megabyte. So, which of those you are constrained by really depends on how big your individual messages are. And so this is sort of the steady state of what you can expect your Lambda function to be handling, right? So this is the limit on the right side. So, it holds that in most situations, that's going to be the limit of what your Lambda function is going to be trying to process. But there are edge cases where your Lambda function could take, more messages and more data. And so those max limits are 6 megabytes from a size perspective is the most that a Lambda function can take in on a synchronous call. And 10,000 records is the maximum number of records that you can set in your batch size for the Lambda service to deliver to a single Lambda invocation. So those edge cases could be maybe your Lambda was erroring, you pushed some bad code, it wasn't processing messages, you push some new code to update that Lambda to fix it, and now it's got a backlog of messages to go through. Then you might see some of these larger batches, that sort of thing. So, just good to keep in mind kind of what that steady state performance looks like and what the potential max could be. So some best practices around, how to scale Kinesis in general. So you can auto-scale your shard count using application auto-scaling. There's a blog there that details that. If you are using auto-scaling, even if you're not, definitely, be a little bit conservative. Leave some headroom so that if there's bursts of messages that come in, you're not throttling clients. The shard count generally doesn't drive a lot of the cost of Kinesis, so having 10% extra shards, 20% extra shards isn't going to break the bank. And then think about how your Lambda is going to scale in terms of those max messages coming through. So one more detail on splitting shards that I do like to call out in terms of if you're scaling up is that we talked about earlier how, at least under normal circumstances, there's that one-to-one relationship between the number of shards and the concurrent Lambda executions. If your Lambda function is a bit behind, and we talk about iterator age as where that iterator, that marker in the stream is in terms of how far along the Lambda has processed, if your Lambda function is a little bit behind and you go to scale up your stream as a way of increasing concurrency, keep in mind that Lambda has to catch up to the end of the current parent shard before it starts reading from the child shards. So basically, as you update from 2 shards to 4 shards, new data that's being put in is going to be going into those new 4 shards. But remember, Lambda is making sure that you're processing things in order, so it has to finish processing the parent shard before it starts processing the child shard. So if you increase your shard count but don't immediately see an increase in Lambda concurrency, that could be the reason why. All right, So DynamoDB Stream scaling works in a similar way. So DynamoDB Streams also have shards, but unlike Kinesis, you don't have direct control over the number of shards, right? Depends on how big your table is, how much throughput it's doing. And that brings us to the two modes that DynamoDB tables have in terms of how their capacity is managed. So the first here is on-demand capacity. This is definitely what I recommend people start out with. You don't have to worry about capacity at all. It's really good for spiky workloads. The capacity is just managed for you on the back end, and you pay just for the requests that you make, reads and writes to the DynamoDB table in terms of the throughput to it. Works really well for bursty workloads, works really well with a lot of serverless workloads as well. The other option is provision capacity. Here, you have that RCU, the read capacity unit dial, and you have the WCU dial, and you can turn those independently, tune that according to your workload, and you can optionally auto scale them. And so this is a really good option if you have a workload that's kind of really steady state, or maybe you have a workload that kind of slowly ramps up over the course of the day and then goes back down. Auto scaling will keep up with that really well. And for kind of from a cost perspective, it's slightly cheaper to go this route if you can kind of correctly match your workload and you don't need to do a lot of over provisioning. So those are the kind of two options there. The reason that this is important for our scaling workload is that on-demand tables under the hood, the way that they work, and the details there, from the Dynamo docs, the way that they work is, if you do have some really big spikes in your on-demand table, in the background, that table basically will kind of double its capacity to be able to handle bigger spikes in the future. And when you double the capacity of a table, in general, you also double the number of shards in the DynamoDB stream. So with on-demand tables where you're reading from the corresponding DynamoDB stream, you have this possibility of having really big spikes in Lambda concurrency. So the key takeaway here is to just be aware of this behavior if you're reading the stream from an on-demand table, and just make sure that you have enough overhead in your Lambda concurrency limits to handle these spikes. So set some alarms on Lambda concurrency at the account level. Look at this on the account level, and also for any individual functions where you have those limits set, those reservations set as well. All right, so let's talk a bit about monitoring. So with Kinesis Data Streams, there are places to monitor both on the Kinesis Data Stream itself, as well as on the Lambda function. On the Kinesis side, some of the really interesting ones are the incoming records and incoming bytes. This gives you, a leading indicator in terms of what your Lambda function is going to see, right? How many records are coming in? Are those records, maybe the number of records stays the same, but maybe the records are bigger, and you'll see that in the incoming bytes. These metrics, you can also get shard level detailed metrics. This is an option that you can enable on your Kinesis stream if you want to see that level down at the shard level. That can help you know if you have an imbalance in kind of how your records are coming in, what you're choosing for that Kinesis partition key as they come in, which determines which shard they use. So that's a good tool to use as well. On the Lambda side, you have errors. Is your Lambda function throwing any errors? Throttles, right? These are metrics that you're probably familiar with if you have other Lambda functions. One that you may not be familiar with is iterator age. That iterator age is basically how far behind the most recent record is your Lambda function reading. So if that's a few milliseconds, you're basically very much caught up to now in the stream. If that starts to be 10 minutes, 15 minutes, 30 minutes, it means you're falling behind. So that's a good metric to look at to understand the performance of your Lambda function, and are you keeping up with that incoming stream of records or not? So an important one to see there. Duration matters because it will basically influence iterator age, right? So if you push a new version of your Lambda function and the duration suddenly doubles, there's a good chance if your stream is busy that you're now going to be kind of further behind in reading that stream. So just important to think about these metrics. On the DynamoDB side, very kind of similar metrics. The stream itself has kind of fewer metrics in this case, but on the Lambda side, the metrics are very similar. You're again going to want to watch that iterator age. With DynamoDB, it's kind of even more important to watch iterator age because with DynamoDB, the records age out of the stream within 24 hours. With Kinesis, by default, it's 24 hours, but you can extend that. You can grow that time if you want to via the APIs, the CLI for a given stream. You can't do that with DynamoDB Streams, so important to alarm on iterator age for sure. I didn't put metrics for the DynamoDB table itself, but certainly writes on the DynamoDB table translate into records on the DynamoDB stream. So, monitoring kind of how many writes, again, it's sort of like a leading indicator to how busy your Lambda function is going to be. So let's talk about a few common issues. Some of the ones that we see are that iterator age growing rapidly, right? Common issue across both DynamoDB and Kinesis Data Stream Lambda consumers. Read throughput exceeded throttles on Kinesis, or that rapid growth in Lambda concurrency with DynamoDB Streams. So let's talk about how we look at those. So if your iterator age is growing rapidly on your Kinesis data stream, some of the things that you just want to look at right off the bat. How many Lambdas are subscribed, right? Is it just 1 or 2? Fine. Is it 5? Is it 6? You might be approaching that limit of how many Lambda functions can be subscribed there, and they might be getting throttled and not keeping up with the stream as a result. Is your Lambda function throwing errors? Is your Lambda function throttling? Both of those could lead to getting further behind in iterator age. And then the front end of that. Is there a burst of records coming into Kinesis data streams that you can see in the metrics? Could be that that's what it is, that there's just a lot more records or a lot larger records coming into the stream. And so the Lambda function is busier. Maybe it's not quite able to keep up. If that's the case and it's a temporary condition, it could be fine, right? If, on the other hand, it seems like it's something that's going to persist, you may want to either scale that Kinesis stream, adding more shards, or look at parallelization factor, which we'll dive into, which basically creates more Lambdas per shard to speed up that throughput. The other thing is just tuning that Lambda function. So maybe the Lambda function currently has 512 megabytes of memory. Remember that CPU and network are proportional to the memory assignment. So maybe you double that, maybe you triple that up to 1.5 gigs. Having more CPU, having more memory, more network throughput, maybe that Lambda can process more records more quickly. Important things to test out in your unit tests of that Lambda function to make sure that you're going to be able to hit those performance numbers you need to. If your Lambda function's erroring, right, you need to figure out why it's erroring, fix that. Maybe you roll back to the previous version, maybe you roll forward. And then throttles, right? So if you're getting throttled from a Lambda perspective, from your Lambda account limits, that's a support case to raise those limits up. We talked about these as the solution. So what about if you're getting read provisioned throughput exceeded on your Kinesis data stream? This basically means that you are doing too many reads per second or pulling too much data off of that Kinesis data stream. And so that could be just basically having too many subscribers on that stream. One option here is to use enhanced fanout. This basically gives a dedicated read pipe to a specific application or a Lambda function from your Kinesis data stream that doesn't take up one of those kind of 5 reads. So that's a good thing to look at. If, on the other hand, you have a DynamoDB stream where that iterator age is growing rapidly, some of the initial things that you want to look at are the same, right? So you want to look at how many Lambda functions are subscribed. Remember that limit's lower here. So it should really only be 2 Lambda functions. If you have more than that, we have a fix for you. We'll do a Lambda fan out, basically. The other things, errors, throttles are the same as before. Again, the duration matters, right? So if you pushed a new version of your Lambda function and the duration has increased, maybe you didn't push a new version of your Lambda function, and it's just that some downstream API that you're calling suddenly is taking longer, right? That type of thing definitely matters. If you need to dive further into kind of why that latency is increasing, take a look at X-Ray, right? So X-Ray, if you haven't used it, helps you really figure out where in your Lambda function you're taking up the most time. And then, look at the kind of other end of the chain, right? Look at the DynamoDB table, look at the WCUs. Are there just a lot more writes coming in, right? That's a good thing to know. And then you can also look at the returned record counts and returned bytes to just see, are there just more coming in from the stream? So both places to kind of ways to check the same thing, just further in different spots on that chain. If you have too many Lambda consumers on a DynamoDB stream, one of the things that you can do is to basically have one Lambda that just forwards records from the DynamoDB stream into a Kinesis Data Stream, and then you can have more consumers read off that Kinesis Data Stream. So that's what I'd recommend if that's the problem, if the number of consumers is the issue. All right, so let's finish up with some discussion of performance and optimization. So important to think about what matters to you overall on your kind of streaming system. Are you aiming for the lowest end-to-end latency possible? Are you trying to optimize around cost? Are you trying to never lose a single record, right? All of these things important to understand, and you may make different trade-offs depending on what those answers are. So, one option to reduce that overall latency with Kinesis Data Streams is to use enhanced fanout. So I mentioned earlier, enhanced fanout provides that dedicated read pipe off of that Kinesis Data Stream, and you can subscribe a Lambda function to it. The other thing that it does is instead of that Lambda service polling the Kinesis Data Stream once a second to get new records, it actually makes a HTTP2 connection and records are pushed to it as they're available. We see this reduce that kind of overhead latency by over 65%. So if latency really matters to you in your streaming data processing with Lambda, this is a good option to use with Kinesis. So the other relatively new feature is parallelization factor. I mentioned this earlier. So we talked earlier about that one-to-one mapping of Kinesis shards to concurrent Lambda invocations. And if a single Lambda invocation isn't able to keep up with a single shard, maybe you're just doing lots of heavy processing on that data, maybe you have to do a lot of outbound network calls, API calls, whatever the reason may be, one of the options is to use parallelization factor. It still maintains in-order processing per partition key. So, within a shard, you're going to have multiple partition keys still, and it's going to batch them up per those partition keys. So you're still getting that in-order processing per partition key. The one limitation this means is that if you have a giant spike in a single partition key, so a ton of records are getting pushed into the stream, and they all have that same partition key, then this isn't going to help you. But in most situations, that shouldn't be the case, right? So you might need to think about a different partition key if it is. But this is a great option to just kind of increase the overall throughput. You can also set this up with application autoscaling if you want to. So if you wanted to say alarm on iterator age to increase parallelization factor automatically, that is something that you could do. Again, just test be a little conservative with it, but this is definitely a good option for getting more throughput. So another common thing that we see is small messages in Kinesis. So if you're putting lots of small messages onto the stream, on that per shard limit, you're really running into that 1,000 per second limit rather than that 1 megabyte limit. And you can gain a lot of efficiency by aggregating those smaller messages together on the client side before you push them into Kinesis. So, this is definitely a good thing to think about if you do have workloads like this that have lots of small messages. We have libraries to help with this. So on the producer side, if you're using the KPL, the Kinesis Producer Library, it will do this for you. There's also the Kinesis Aggregation Library that's available to do that. And then on the consumer side, there's that similar aggregation library that will do the deaggregation as well. The other option here, if you have really like a fixed schema of what your records look like, there are some customers that kind of aggregate stuff into Avro and do it that way. So some other options there as well. So another optimization is for kind of low throughput streams. So maybe you have a stream that for part of the day or for most of the day sees very few records. It comes in relatively slowly. If that's the case, you're going to get Lambda executions that only have 1 record, 2 records, small amounts of records, and it can mean slightly more inefficient processing. So if that's the case, you can take a look at batch window. And what batch window does is for these streams that really have like sparse records that don't see a lot of traffic, you can set a window up to 5 minutes. You set it in seconds. And basically, it will wait up to that window to collect more records before sending them on to your Lambda function. The cool thing about this is that it still respects batch window first. So if I have it still respects batch size first. So if on my stream configuration, my consumer configuration with Lambda, I had set a batch size of 100 and the stream is really busy, it's going to just keep sending me batches of 100 records. Batch window isn't going to come into play at all. But if then the stream really slows down, you're only getting 1 or 2 records per second, and you set a 5-minute batch window, it's going to wait until it's aggregated up 100 records or until that batch window runs out before sending me batches of records. So really cool, works with both Kinesis and DynamoDB Streams. So a good option for streams that have periods of the day that they're lower throughput or just lower throughput in general. So quick summary of those new controls that we talked about. So a lot of those error handling controls are available for both Kinesis and DynamoDB Streams. Those error handling controls are not available if you're using an enhanced fan-out consumer. So important to kind of understand that there. And then some of those retry mechanisms are available for asynchronous info. So I put that there as well. Some other sessions that I'd encourage you to check out if you found this useful. So a deep dive on Kinesis, and then scalable event-driven architectures. So SQS, SNS, if you're interested in that should be a great one as well. I really appreciate you taking the time today. Any feedback, thoughts, feel free to reach out to me on Twitter. And then I'd really appreciate it if you completed the session survey. Thanks again for your time, and I hope you have a great reInvent.